Okay, so the conjugate zeros theorem says that if you have a complex number that's a zero of a polynomial with real coefficients, then the complex conjugate of that number is also a zero. So, for example, if I know that 1 plus 2i is a zero of f of x with real coefficients, then I know that 1 minus 2i is a zero. Okay, let's take a look at a more concrete example. So x squared plus 4. Let this be our function. To find the zeros of f of x equals x squared plus 4, I set x squared plus 4 equal to 0. So that tells me that x squared is equal to negative 4. So the zeros are x equals plus or minus the square root of negative 4, which is plus or minus 2i. So the zeros of this are 2i and negative 2i, which are complex conjugates. Let's do another example. So we wish to find a cubic in factored form that has real coefficients, a leading coefficient of 5, and zeros that include 9 and 7i. Well, by the conjugate zeros theorem, we know that since 7i is a zero of this cubic with real coefficients, negative 7i, the complex conjugate of 7i, is also a zero. So that means that f of x equals the leading coefficient of 5 times x minus the first 0 times x minus the second 0 times x minus the third 0. And so this is equal to 5 times x minus 9 times x minus 7i times x plus 7i. Real coefficients means that none of these x's are allowed to be multiplied by a number that has I in them.